All right, this one's going to be a doozy. Big topic here, acceleration. So we're going to jump right in. There's going to be a lot going on here. So try to get down as much information as you can. And I would suggest repeatedly, maybe listen to it once and then go back and listen to it again and take notes. All right, so here we go. We're going to learn today about acceleration. So probably the first thing we need to do is learn about what acceleration is. So far in all the problems we've done, our objects have been moving at a constant velocity. So the object's velocity, which was constant, was the same as the object's average velocity. So pretty much everything that we've done so far has dealt with average velocity. All right. So what do we do if the object's instantaneous velocity is changing? Well, we're going to find what's called the acceleration. Here's the definition for acceleration. It is the rate at which an object's velocity changes. The symbol that we're going to use for acceleration is a lowercase letter a. All right. So think about it. The definition refers to a couple things. It refers to the velocity changing. Usually, when you think of an object accelerating, you think about it speeding up. Like you might say, hey, Carl, people are going to be mad at you if you get on the freeway at 25 miles an hour, so you should accelerate before you get on the freeway. So here you're telling them to speed up. Okay. However, technically, to accelerate, all an object needs to do is change its velocity. Okay. That is super important. To accelerate, all the object has to do is change its velocity. And remember, as we've seen before, there are 3 different ways to change your velocity, but only 2 ways to change your speed, right? Okay, so we learned that the 2 ways to change your speed were speed up, and the 3, or slow down, sorry, speed up or slow down. And the 3 ways to change your velocity are speed up, slow down, or turn. So this is super important. If you do any of these 3 things, you are accelerating. Okay, if you do any of those 3 things, you're accelerating. So people always say, well, what about deceleration? In physics, we don't use the word deceleration. Okay, what's actually going to happen is usually if you slow down, that'll end up, this is sloppy, but basically being a negative acceleration. Okay. Also, please keep in mind here that we are now talking about instantaneous velocity. When you speed up, slow down, or turn, you're changing your instantaneous velocity, and that's what we're going to be interested in. Okay. So an object is accelerating anytime it changes its velocity, if it does one of those 3 things. So acceleration has a numeric value. In other words, in the same way that you can say the velocity of an object is whatever, 5 meters per second, you can also give a numeric value to acceleration because it measures the rate at which an object's velocity changes, or how quickly the object's velocity changes. All right. So let's do a couple quick examples. What we're measuring here is how quickly the velocity changes. All right. So example number 1. Imagine being in a large school bus at a red light. You look out the window and there's a Corvette or some other crazy fast sports car next to the bus. Sorry, I'm kind of reading to you here. So the light turns green and both the bus and the Corvette speed up to a speed of 45 miles an hour. Picture that in your head, you guys. You've got a Corvette and a bus. The light turns green and both drivers are going to stamp on the gas pedals. All right. The Corvette's going to get to a speed of 45 miles an hour very quickly, and the bus is going to take a while to get to that speed. The Corvette there has a big acceleration because it's gaining speed quickly, whereas the bus is going to have a very small acceleration because it gains speed much more slowly. Okay, so that is one example of acceleration, and eventually we're going to assign numbers to these. Okay. Example 2. Imagine this. Imagine 2 identical cars driving at 50 miles an hour. Car A is going to stop his car by slowly pressing the brake pedal. Car B is going to stop his car by driving it into a brick wall. Okay. Both cars are changing velocity. Both cars are accelerating. Okay, because they're both changing velocity. They're both going from 50 miles an hour down to 0. The difference is car A is changing its velocity slowly, so it's going to have a small acceleration, while car B is changing its velocity very quickly, right? You're going from 50 miles an hour to, bam, 0 miles an hour, okay, in a very quick amount of time, okay? I should comment that even that car driving into the brick wall, it does take time for that velocity to go to 0. The car does not immediately stop. It stops very, very quickly, but it's not immediate, okay? All right, so I'm going to flash on the screen here a few questions. I'd like you to read them, pause the video, read them, and try to answer them. So pause. Cool. I'm going to assume you've now paused the video and answered these questions. Can an object change its velocity without changing its speed? And the answer is yes. Just by turning, right? Okay. Can it change the speed without changing its velocity? And the answer is no, because to change your speed, you got to speed up or slow down. And if you do that, you've changed your velocity. Okay. Same thing. For each of these, I want you to tell me if the object is accelerating, and if it's not accelerating, write constant velocity next to it. Yeah, if it's accelerating, you can also say why. You can tell me that it's either speeding up, slowing down, or turning. Okay? So tell me if the object is accelerating or not, and why, or if it's not accelerating, so the velocity is constant. So pause, stop and think about them. Okay, here we go. Car speeds up from a stoplight. That is accelerating because it is speeding up. A biker hits the brakes to avoid hitting a cat. That is accelerating because it's slowing down, right? When you hit the brakes, you're slowing down. Okay, a car drives straight north with the cruise control set at 60 miles an hour. Let's see, it's not speeding up. It's not slowing down. It's not turning. And that means that the velocity is constant. That one is not accelerating. Okay. You're walking at 2 meters a second when you turn a corner without speeding up or slowing down. Even though you're not speeding up or slowing down, you are, in fact, accelerating because you are turning. All right. Flower pot falling off a windowsill will accelerate as it falls because as it falls, it will speed up. And then this last one, a skateboarder rolling down the hill, is actually the same thing. It's accelerating. Sorry, there's no room there. It's accelerating because it is speeding up as it goes down the hill. Okay, so which of these objects is going to have a bigger acceleration? Oh, sorry, pause it and think about it. Cool. All right, so this one's going to have a bigger acceleration. We'll learn more about that later. I wouldn't stress over that one. Which one's going to have a bigger acceleration is the motorcycle speeding up. And on this one, it's going to be an empty shopping cart is going to accelerate faster if you push them both with the same force. Okay, again, we'll learn more about this one later on. All right, so now we have a good idea for what acceleration is. Now we need to learn how to calculate acceleration. All right, this is huge. All right, it says we have a pretty good idea of what acceleration is, but how do we calculate it? Well, to find acceleration, you're going to figure out how much the velocity changes and divide it by the time it took for that velocity to change. Here is the equation you're going to use most often. This equation is super important. It's going to come up the rest of the year. You must understand the concept of acceleration. Okay, so let's run through this. Zoop. You gotta make sound effects. Sorry. All right, so what are the variables? Well, A is acceleration, the acceleration of the object. All right, now we're going to start using some subscripts here. So we've got here VI and VF. VI is what we call initial velocity. That's the velocity that the object begins with. So before the velocity started to change, what was the velocity? Okay, and final velocity is the velocity at the end of however much time you're looking at. Okay, so if you're talking about in those previous examples, the car driving into the brick wall would have had an initial velocity of 50 miles an hour and a final velocity of 0. For the school bus and the Corvette, the initial velocity would have been 0 because they were at a red light, and then the final velocity was, I think, 45 miles an hour. Okay, and then finally, the T, this happens all the time. I ask people, what does T stand for? And people say time. Yes, it is time, but from now on, you need to think about the time for what? Okay, and in this case, it's the time that it takes for your object to get from the initial velocity to its final velocity. Okay, so this idea here is colossally important. All right, so we're going to do a couple examples here. This is totally going to go 2 videos, so I apologize, you guys. I really try to keep these short, but this is a really big concept. So anyway, we're going to do a couple examples. In this first example, we're going to use miles per hour to measure the velocity, just because it's more familiar to you. You guys all know what 1 mile per hour is. And when I say miles an hour, I think you're able to visualize that as being velocity. Eventually, we're going to have to switch over to meters per second. So just so that you know that's coming down the road. Okay, here we go. Example number 1. All right, so lots of car magazines. Oh, the answer's already on here. Don't look at the answer yet. In a lot of car magazines, it'll tell you the amount of time it takes for a car to go from 0 to 60, which tells you how long it takes for the car to go from a dead stop up to a speed of 60 miles an hour. All right, so really fancy cars will do it in under 5 seconds, but for simplicity, let's suppose that it takes 5 seconds. All right, so the first thing that you need to do is write down what you know. Okay, so in this problem, there's 3 things that we know. Oops. We know that the initial velocity was 0 miles an hour because the car is not moving at the start. We know the final velocity is 60 miles an hour because that's the speed, or the velocity, I should probably say, the velocity the car reaches. And we know that the time that takes is 5 seconds. All right, so we're going to try to find the acceleration, which is what the problem says to do. Okay, so to find the acceleration, we're going to use the equation, Vf minus Vi over t, and you plug in your numbers. And so look what happens. We get this. Our final velocity was 60 miles an hour. Our initial velocity was 0 miles an hour. So I did Vf minus Vi divided by the time, right? So you get, I'm sorry, the formatting on this is terrible. So you end up getting 60 miles per hour in 5 seconds. So what that's telling us is the car's velocity changes by 60 miles an hour in a time of 6 seconds, which means the velocity changed 12 miles per hour per second. Okay, I'm going to say that again. 12 miles per hour per second. All right, so what does that mean? Well, here's what it means. Let me do this. We're going to color code. Here's what it means. It means every second, the velocity increases. And the reason we know it increases is because this is a positive number by 12 miles an hour. Okay, so think about the speedometer as you speed up in a car. As you speed up, the needle points to increasing speeds. So let's click ahead. Here we go. So let's look at this. When our car began, it was at rest, right? So there's our speedometer. Okay, and what we just decided was the speed's going to go up by 12 miles an hour every second. So after 1 second, the speed is going to be 12 miles an hour. After 2 seconds, it's going to be 24. After 3 seconds, it's going to be, what, 36? Oh, that's the worst arrow I've ever drawn. After 4 seconds, the velocity will be 48. And after 5 seconds, the velocity will be 60. I just got that by continually adding 12 miles an hour. Okay? You can also figure that out by making a chart. Okay? So here we've got time and velocity. The velocity starts at 0. Velocity begins at 0, and then every second it goes up by 12 miles an hour because that's what the acceleration is, and that happens until you get to 60 miles an hour. So in this example, the acceleration is 12 miles an hour per second because every second the velocity increases by 12 miles an hour. You're going to hear this over and over until you're ready to punch me. It is super important. People historically have had a problem of calculating acceleration without understanding what it means. You must understand what acceleration is. All right, I'm going to stop the video here. There's going to be a part B to this video, so please make sure you watch part B. I apologize for this video being so long, but again, this is a really, really important concept. All right, so pause, and we're going to watch another video.